This is the video for section 4.4 notes, slide number 25. All right, it says given that h of 2 is 5, h prime of 2 is 0, and h double prime of x is negative 3 x squared times cosine of pi over 3x. Determine whether h of 2 is a local minimum, maximum, or neither. All right, and so we are using the second derivative test here. Okay, so remember, second derivative test says if h prime of 2 is 0, then we want to know if h prime of 2 h double prime of 2 is positive or negative. That would tell us whether or not we have a local minimum or local maximum. All right, so take a look at this graph. All right, you notice that the derivative is 0, right? So f prime equals 0 here. And what can you say about f double prime, right? F double prime is greater than 0. It's positive, right? Because this curve is concave up. So that means there's a local minimum there, right? All right. If we have a local max, once again, we know that f prime is 0, but then f double prime is less than 0, right? Because this is concave down. And so we could say we have a local max. All right. And so what we are told is that h prime of 2 is 0, right? So that satisfies the first part that is necessary to use the second derivative test. But now we need to evaluate h double prime of 2. All right. So h double prime of 2. So negative 3 times 2 squared times the cosine of pi over 3 times 2. All right. And so I have negative 3 times 4, right, times the cosine of 2 pi over 3. All right, so negative 3 times, so that'd be negative 12 times the cosine of 2 pi over 3. Cosine of 2 pi over 3 is in quadrant 2, so we get negative 1 half, right? And so negative times a negative is positive, and we get 6. So h prime of 2 is 0, and h double prime of 2 is 6. Therefore, we must have a local minimum, right? Because h prime is 0 and h, not f, h double prime is greater than 0. Therefore, h of 2 is a local minimum. All right, so that is slide number 25.